Okay, these questions here, they talk about transformations. Terrible writing there. And what we're going to do is instead of actually graphing them out, we'll show on a graphing calculator, we're going to refer to the original function. So we have two that are cos functions and two that are sine functions. Now, the parent function to these being y is equal to a, then whatever the function is, so we'll use function notation. This f can be replaced by either sine or cos. It doesn't actually matter, okay? Then we have the b value, x plus c, or horizontal shifts, and add the value of d at the very end. What we're going to do in these four questions is we're going to figure out which of these numbers pertains to a, b, c, or d, and what that means in terms of a vertical or horizontal compression, or vertical translation, or horizontal translation. And we'll just kind of write that out. So the very first one, you'll notice it's before sine, which means this is an a value. There is no b value, which actually means the b value in this case happens to be 1. So I'll give us some equivalencies. A is equal to -2 here. If there's nothing for b, because there's no value being multiplied by x, okay, you'll notice there's nothing here. This actually means it's a value of 1. And the defaults for, just as a side note, the defaults for all of these, a is defaulted at 1, b is defaulted at 1. And when I mean defaulted, what I really mean is for sine x, a is 1, b is 1, c is 0, and d is 0, okay? So keep those ones in mind. So something's missing, that's what those values actually happen to be. C in this case, we do have a value that's being added to our x, our independent variable. It happens to be 10, so it's 10 degrees. They didn't do these ones in radians. These are all in degrees here. You can do a conversion of radians if you want, but C is 10 degrees. So that's actually a shift to the left, okay? And then notice we don't have a D, so D actually happens to be 0 in this case also. So that means vertically there's no shift, it's at 0. C gets shifted to the left. B is 1, so there's no horizontal compression or stretch. And A is -2, so this actually gets flipped on the x-axis. So if the waves were like this, they now look like this. They're doing the opposite. And they've been stretched by a factor of 2, which means they're just going to be twice as long at their max and their minimum. That's what the very first one means, okay? Let's jump to the second one here. A value is a fifth, okay? So instead of being a vertical stretch, this is a compression. It shrinks everything. So if before our periodic function looks something like this, it now has a much smaller, oh, that was not very well done, much smaller maximums and minimums, okay? The B value here is 3, okay? So what that means is we get a horizontal compression. So again, if the original looked something like this, okay, where one period took, whatever this is, let's say it was 2 pi, the original. This is now, there are 3 periods within that same amount. So you're talking 1, 2, 3, okay? That's what that 3 value does. So we have a horizontal compression. These are not very symmetrical. We'll show it on a graphic calculator, but that's the general idea to it. The horizontal shift, because it's -15, okay, so -15 degrees, this actually means it's a shift to the right of 15 degrees. And the D value is 1. And because it's +1, it means it gets vertically translated up 1 unit, okay? Let's quickly go through cos. A is 1, so there's no change. B is -5. So this actually gets flipped on the y-axis. So if we had something that looked like this, on the y-axis, it's actually going to give us this object now because it's negative. And because it's a value of 5, it happens much more frequently. So something like this, not very well drawn, but that's the general idea to it. We have -2 for our C, or negative pi over 2. So C is negative pi over 2, which means it's going to shift to the right pi over 2 units, and the D value is 7, so we get a positive vertical shift upwards. And then finally, the very last one, A value is -1, so that means it's going to flip the period. So if it looked like that, we get a flip on the x-axis. It looks something like this now, which looks pretty similar from before. The B value is 1/4, okay, so B is equal to 1/4. What that means is if the period looked like this, it's actually extremely elongated, so it looks something like this. Okay, so where one period happens, it takes 4 times as long for that same period to occur. The C value here happens to be 37 degrees, and it's positive, so it's being shifted to the left. 37 degrees. And the D value is negative 2, which means there's a vertical shift downwards by that amount. So this is just a way of representing that stuff. Graphically, we'd show all those same concepts, but this is a quick way of showing those vertical translations and stretches and compression.